now let's move on to the next question. The next question is somewhat a different one. A different one in the sense that in the previous sessions, in the previous two examples, what we have seen is the projection was given, the projections, that the distance between the n projectors, the distance of A dash from xy, distance of A from xy, distance of B dash from xy, distance of B from xy was given. So using those 5 data, we were able to complete all those drawings, the complete drawing, we were able to complete it. And now if we are given the true inclinations as well as the true length and position of one of the points, then how to draw it? So that is the question. The reverse. In the previous 2 cases, we found out the true length and the true inclinations. But in this case, the true length and the true inclinations are given. You have to find out the projections. So let's do it. So the question is, the line AB is 75 millimeter long and it is 30 degree and 40 degree inclined to HP and VP respectively. End A is 12 millimeter above HP and 10 millimeter in front of VP. Draw the projections. Line is in first quadrant. So in this case, the true length of the line AB is given. It is given as 75 millimeter. And true inclinations with HP and VP are also given. True inclination with HP is 30 degree and true inclination with the VP is 40 degree. That is, theta is 30 degree and phi is 40 degree. That is given. Then the distance of end A above the HP and in front of VP is given. That is, it is the distance of A dash from XY will be 12 millimeter above XY and that of A will be 10 millimeter below XY. So these 5 data are given. That is the true length, the true inclination with HP, true inclination with the VP, and the distance of the point A from HP and VP. Now what we have to do is we have to draw the projections. And that the final statement, line is in first quadrant. Actually, it is not required in this case. In most of the cases, unless it is specified, we consider the line to be in first quadrant. So in this case, first we go for our base figure. Here the base figure, the true length is given. So the true length is 75 millimeter. Here is 75. Here also it is 75. So these 2 values we obtained. True values, true length. Then theta equal to 30 degree. Here it is 30 degree. Theta is 30 degree. Alpha we doesn't know. Here also phi is equal to 40 degree. This also we know. We doesn't know beta. This is phi. Phi is 40 degree. Theta is 30 degree. And this distance of A dash from XY, that is 12 millimeter. Since here it is given as 12 millimeter above HP. So it is 12 millimeter. And 10 millimeter in front of VP means this distance is equal to 10 millimeter. So this much we have. That is, the true length of the line is 75 millimeter. The theta is 30 degree. Phi is 40 degree. The distance of A dash from XY is 12 millimeter. Distance of A from XY is 10 millimeter. So this also I will solve in open board and then you can proceed it along with me. Okay. So let me first insert our base figure. So here is our base figure. here the true length. Here is the true length. This true length is equal to 75, and this theta equal to 30 degree, and phi is equal to 40 degree, and here also this is the true length equal to 75, and this distance is distance of a dash, that is 12. Here distance of a, that is 10. So this is the given data. Now what we do is we have to so based on this figure, based on this particular data, we have to complete the drawing. Oh, okay, this one is there. Draw the straight line, that is xy line is to be drawn first. So this is our xy line. Mark it as x and then y. So the xy line is here. Now what we have to do is we have to mark the distances 12 millimeter and 10 millimeter, so that first we locate a dash as well as a. So in order to do that, first we locate an arbitrary point on the xy line, and from this line we draw a perpendicular line. This perpendicular line is the projector of A. That is so this is the projector of A, and in this projector of A you have to mark distances 10 millimeter as well as 12 millimeter. 12 millimeter above the so I am marking it from 13, so it should be 14.2. 12 millimeter means 14.2. So here is a dash, and 10 millimeter below means 12. So here is A. So this is point A dash. And this is point A. Now from A dash and A, we draw the locus of A dash as well as locus of A. Why we need it? Because one thing is we need to measure the angle from this line, and the second one is we need to draw this one in order to get the locus in order to, when we rotate the points, we need to obtain the points B2 dash as well as B2, I mean B1. So for that one also we need the locus of these 2 points. So locus of A dash is marked as well as locus of A. So both locus of A dash as well as locus of A is marked. So this is once A dash as well as A is located, you can directly draw A dash locus of A dash. That is this horizontal line as well as the horizontal line through A. It is not visible here, but we know that there is a horizontal line here. So the locus of A, that is these 2 lines. These 2 lines we have already mark. Then from A dash, mark an angle equal to 30 degree. From this point, from A dash, mark an angle equal to 30 degree. So here is 30 degree. And then join A dash with this line and extend it to some distance so that we should be able to mark at least 75 millimeter on this particular line. So we extend it to some distance so that we can mark a distance equal to 75 millimeter on that one. Now we mark a distance which is equal to 75 millimeter. So this is the way we find out the point B1 dash. So we found out the point B1 dash here. So the point B1 dash is obtained, and once B1 dash is obtained, we can find out the locus of B dash. The locus of B dash is a horizontal line which is parallel to the XY line and passing through the locus of the point B1 dash. So this is the locus of B dash. So we can mark the points. This is point B1 dash. This is the point B1 dash, and this is the locus of B dash. So this means that B dash should be lying somewhere in this line. So that's it. Now, once we got B1 dash, we can find out B1. B1 is the line which is lying in a perpendicular line which is passing through B1 dash, and it should be lying in the locus of A. So if we draw a perpendicular line through B1 dash, perpendicular line through B1 dash, and when that particular perpendicular line intersects with the locus of A, through the locus of A, then we get the point B1. So this is the condition. So now the condition is that the line is parallel to VP and inclined at an angle theta degree to HP. That is the condition. Right now what we have drawn is the condition when the line is parallel to VP and inclined at an angle theta, that is 30 degree to VP. That condition we have drawn. So in this case, AB1 will be equal to the the top length of the top view. The length AB1 is equal to the length of the top view. So up to AB1 we have completed. The length of the top view we have found out. Now we need to find out the length of the front view. In order to get the length of the front view, what we have to do is we have to mark a distance of 40 degree, the 40 degree distance from point A. So for that one we have to rotate it in the opposite direction, and from here. Mark an angle of 40 degree. Here the 40 degree is to be measured from here. So the inner marking is to be noted. Inner marking 10, 20, 30, 40. That is to be noted. And so it coincides with the 140 degree. So here it is. Here is the 40 degree inclination. So that is there. Now we drop a straight line from the newly marked point and from A. So this is the 40 degree line. So here is the 40 degree line, and on this line you mark distance equal to and in this point distance 7.5. centimeter or 75 millimeter is to be marked. So 75 millimeter is marked here. So this is the point. So this is the point B2. It is the point B2. It is point B2. Now draw the locus of B. Locus of B is a line which is parallel to XY line and passing through B2. So the locus of B2 can be drawn here. So this is the locus of B2. Locus of B2 is obtained. So now we can find out the point B2 dash. B2 dash is obtained by drawing a perpendicular line or a line which is perpendicular to the XY line, that is a projector through B2, and that particular line when intersecting, or the projector when intersecting with the locus of A dash, we will get the point B2 dash. This is the point B2 dash. So now A dash B2 dash is the front view length. If you consider A B2 and A dash B2 dash, it is the projection of the line when the line is parallel to HP and inclined at an angle 40 degree with VP. If you consider the projections A dash B2 dash and A B2, it is the projection of the line when the line is parallel to HP and inclined at an angle 40 degree with VP. So up to this we have completed. So the length of the front view is also there, that is A dash B2 dash. Now what we have to do is we have to find, since the length of the front view is there and the length of the top view, that is AB1 is there, we can now rotate the length of the front view and the length of the top view such that we can get the final front view and the top view. First, what we have to do is we have to use our compass and draw an arc with the radius equal to A dash B2 dash and with the center as A dash. So we are actually rotating. Now what we have done is we have rotated the front view length. The front view length is rotated to intersect with the locus of B dash. And this point what we obtained right now is the point B dash. So this is the point B dash. See in the base figure, from B2 dash with the center as A dash, if we draw an arc, when that particular arc intersects with the locus of B dash, we obtain the point B dash. So here is the point B dash. Now join A dash with the B dash. So this is our front view, A dash B dash. Now similarly what we have to do is we have to rotate the top view, that is AB1, the top view length AB1 to the locus of B2, I mean locus of B. So sorry, I forgot to mark the locus of B. Here is the locus of B. So this is the locus of B. Now this arc is rotated. So this is rotated, and this point, when the arc of rotation, see from B1, if we drop an arc and when it intersects with the locus of B, we obtain B. So this is the point B. Now join point A with B using a straight line. So this is it. So now as a check, we can check whether this B dash and B are lying in the same vertical line. If both are, there is a slight difference. It's because of some drawing errors as well as measurement errors. if the drawing is perfect, B dash and B should be in the same vertical line. As you know, the projection of 2 points, that is the front view and the top view, will be in the same vertical line. It should be in the same vertical line. Because of some measurement errors, some drawing errors, there is slight variation is there in my drawing. But in your drawing, it is not. It may not be possible because you are using perfect, very good, very accurate measuring instruments, as well as you are drawing it using your hand. Using softwares, it is slightly difficult. So this is how it is being drawn. First, what we do is we consider that the line is parallel to VP and inclined at an angle theta to HP, and thus we draw the projections, that is A dash B1 dash as well as A B1. Then we consider that the line is parallel to HP and inclined at an angle phi to VP. So that is then we obtain the top view as A B2 and front view as A dash B2 dash. So now what we do is, in the previous two steps, we obtain the length of the top view as well as the length of the front view. Then we, in the next step, what we do is we rotate the front view and rotate the top view to the locus of B as well as locus of B dash. So this is how we obtain the drawing, the required drawing. So now let's see an animation of the same thing. So first we draw the XY line, then we draw the projector for A dash and A. And on this one, you mark the point A dash as well as A. And from both the lines, we draw the locus of A dash as well as locus of A are drawn. And from locus of A dash, from the locus of A dash, keeping A dash as the base point, we mark an angle equal to 30 degree. That is 30 degree is 30 degree is the inclination of the line with the HP, so that particular length is marked. That particular angle is marked 30 degree, and you draw a line which is of length 7.5 centimeter or 75 millimeter. So B1 dash is obtained, and now from A we draw another angle that is 40 degree. That is phi is 40 degree and 7.5 degree. 7.5 centimeter or 75 millimeter length line is drawn in order to obtain the point B2. And then locus of B dash as well as locus of B is obtained. And from B1 dash, drop a projector to the locus of A in order to obtain the point B1. And then AB1 is rotated, that is the top view length AB1 is rotated to obtain the B, the point B. It is rotated, the top view length AB1 is rotated to the locus of B. And so the top view is obtained. Similarly, the point B2 is projected upwards in order to obtain the point B2 dash. And then the front view length A dash B2 dash is rotated in order to obtain the point B dash on the locus of B dash. So then join A dash with B dash. So this is the front view. And if your drawing is perfect, B dash and B will be in the same vertical line. And then finally mark the dimensions 12 and 10. Then the angles theta and phi are already there, and the true length also has to be marked, the true length line. So like this, 75. Only one true length is enough, not necessary. The second one is not necessary, only one is enough. Then finally, drop a box in which you have to write down the true length, which is already known, 75 millimeter, theta, which is already known, that is 30 degree, phi, we also know it is 40 degree, and alpha and beta you have to measure from the drawing and measure. I write down it. Alpha is this angle, that is the inclination of A dash B dash with the XY line. So this is alpha, and here this is beta, that is the inclination of the top view with the XY line. So this is beta. So these are the two angles that is missing from this table. This is 75 millimeter. This is 30 degree, and this is 40 degree. And what is alpha and what is beta? Anybody?
Alpha.
Alpha is 40 degree. Maybe somewhere around 40. I'm not sure how much is the angle. And beta?
46 degree.
46.
Okay.
Okay, it is 46 degree. Anyway, alpha and beta, alpha will be greater than theta, as well as beta will be greater than phi. So that is the only thing, that only condition that we know. If you get any value which is less than theta as alpha, that means you have done some mistake. Or if you get a value beta which is less than phi, that means you have done some mistake. Okay.